Okay, item B, intrinsic geometry, exterior algebra, in this case, in war3. Could be, in this case, could be 2D, 2-dimension, you see 3-dimension, doesn't matter, 4-dimension. Now, B part 2, manifold, push forward and pull back. B part 2, lecture HC, numerical example, push forward and pull back. Now, from the lectures 8A and 8B, and to compute the right-hand side of the transformed vector field YQ given. Now it says numerical example. So this is the formula which we derived in lecture 8B. Now this is values, input values, okay? XR, X theta, R theta, this is input values. Let XR 2, X theta 1, R is equal 5, and theta is equal pi over 3. Attention now, all of this belongs to R2, R theta. So I want to obtain just YQ, you see? This is transformed vector field YQ. That's what I want. Now, this is X is equal R cosine theta. This is 2.5. Y is R sine theta, which is 4.33, approximately. Now, first component, coefficient of this basis vector here, okay? This, attention now, belongs to R2 xy. Now you just substitute, you see this numerical value just on the first component, okay? You just copy from here to there. So this is equal minus 3.33. Now the second component, coefficient of, this belongs to R2, x and y. That's what I want. I want this number here, okay? You just copy from here to there. Then substitute these input values over here. Then this leads to 4.232. That's it. That's the final result. So the YQ is approximately equal to minus 3.33. This is basis. This is basis vector. Belongs to R2, x and y. So this is a numerical value. This is a numerical value, this YQ. You see, IQ belongs to this manifold, okay? Euclidean manifold. This is Euclidean to Euclidean. That's a particular case, okay? But that's it. That's quite easy just to follow this formula here, which we derived in lecture 8B. That's it.